afternoon, everyone. Thank you for joining us this afternoon. You're here for our CAD workshop that we are hosting online this year. We're fortunate enough to have VC Silver Circuits as our instructors this afternoon. VC Silver Circuits is a highly successful team that has attended Worlds the last 2 years, and this past year won an award, the Motivate Award, in their division, and also went 11-0 during the qualification matches. And one thing that you would see if you'd seen the robot in person is that it had quite a few customized 3D printed parts that they designed and created in CAD and then printed with a 3D printer. And one of the things we want to accomplish today, hopefully, is to learn a little bit about the CAD environment generally, to kind of walk through a use case and then show you the basics of how you might take that object and work in a slicer to then 3D print that object that you've created. So with that, I'm going to go ahead and turn it over to them and let them give the presentation.
Hi, this is Cohen, and I'm Aiden. We are the VC Silver Circuits Team 16158. This is our 5th year competing in FTC. Last year at the World Championship, we were the first seed alliance captains in the Edison division, going 11-0 in qualification matches. We ended up placing 21st overall. Today, we will be giving a light introduction to Fusion 360. During our first 2 seasons competing in FTC, we didn't even know what CAD was, let alone how to use it to design robots. But through our years as a team, we have learned CAD and have been able to use it to our full advantage. Today, we'll be giving a brief overview of the Fusion 360 workspace, then showing you how to design your own alliance markers to 3D print, and finally, how to export your files and get them ready to be 3D printed. These are the organization tools, which include the top bar, the design panel, and the browser. The top bar has all of the normal things, such as panels to access designs, save, export, undo, redo, and the amazing help question mark in the upper right-hand corner, which you can use if you are confused on anything. The design panel allows you to create generative designs, realistic renderings, animations, and simulations for your designs. These are pretty cool, so you should definitely play around with them sometime, as we are not covering those today. The browser is basically a storage folder to see all of your different designs and parts. This will show you a list of the files, 3D bodies, sketches, and components that you are currently using in your design. This is the design workspace, where we will be spending our time in this workshop. We do not have enough time to go through every tool in Fusion, but Fusion does a really great job of explaining each tool when you hover over it. When we are CADing, we use the Create, Modify, Inspect, and Select panels, as well as the timeline. If you're interested in learning more about these spaces we didn't talk about, there are a lot more resources on the internet, and you're also welcome to email us with any questions. These are the viewpoint tools. The comments panel is used to comment on your designs, which is really useful for projects that multiple people are working on. Or if you forget exactly what you're trying to accomplish, it's a good way to kickstart your memory. The perspective cube is how you change your viewpoint manually. Also, in the little bar at the bottom, you'll find that you can change your display settings and even bring up 4 different viewpoints at the same time if you want to see different sides of your design all at once. Okay, now we'll go into Fusion to cover some of the basic tools. Okay, now that we're in Fusion, we'll talk about some of the basic tools that most beginners use in more depth. As I said before, you can click and drag the perspective cube to view your design all around. Okay. You can also click the center scroll wheel of your mouse to be able to pan your screen, moving your part back and forth, as well as zooming in and out with the scroll wheel. The Solid tab. We will be staying in this tab for the workshop, but if you are interested in learning more about these spaces, there are a lot more resources on the internet, or feel free to email us with more questions. I will give a brief overview of the sections that beginners will be using the most, and then Cohen will show you a demonstration of how to use these tools to design a set of alliance markers for yourself. Sketch. This is where most of your designs will start. It is where you draw your design in 2 dimensions and then later create the 3D object with your sketch. Later, Cohen will demonstrate how to use this tool. When you create a sketch, you need to select the plane you want to draw your sketch on. When you have components or bodies, you are also able to select a face instead of a plane. In the sketch interface, you have access to a bunch of new tools. In this workshop, we will stick with the simple ones. The first one being line.
Why is it not there?
Sorry, the screen sharing's messed up. Okay.
But they can't see.
The line tool allows you to draw a line segment using 2 points. While you're drawing anything, you're able to type in the distance you want. We design everything using the metric system, but feel free to use the standard system if you're more comfortable with that. The rectangle tool. In the Create drop-down menu, you can access multiple types of tools. The rectangle has 3 different types: the 2-point, 3-point, and center. Currently, our screen sharing's messed up.
Bring it to the screen.
Oh yeah,
Just and then change the screen.
Sorry, guys. Okay. With the rectangles, there are 3 types: the 2-point, the 3-point, and the center. For most cases, the 2-point rectangle will fulfill your needs. While drawing a rectangle or any other object with more than 1 possible dimension, you can press CAD to switch between the 2 sides. Once you're done, you can click the screen to finalize your rectangle. Circle. There are 5 types of circles: the center diameter, the 2-point, the 3-point, the 2 tangent, and the 3 tangent. For most cases, the center diameter circle will fulfill your needs. You click the screen and then determine your size, and then you click the screen again to finalize. The sketch dimension. This tool will allow you to create dimensions for certain sketches that don't already have dimensions. It can be used to change the distance between them. It can be used to change the distance between 2 sketches, change the length of a line, or the size of your sketch. It can also change the diameter of circles and many more. Under the Constraints tab, there are a lot of ways to constrain your parts, given the name. But you can lock or constrain certain aspects of your designs with each other. For example, you can lock a line to be tangent onto a circle or an arc, or make 2 lines parallel or perpendicular to each other. In this workshop, we will not be going over these, but if you're interested in learning more about these tools, there are a lot of resources on the internet, or you can email us. Measure tool is the tool used to measure distances between 2 objects, or the diameter of a circle, find arc length, angle between objects or planes, and there's plenty more. This tool has a lot of use cases and is available both in the Sketch workspace and the 3D design workspace. The Finish Sketch button allows you to end the sketch that you've been working on. The Extrude or Press Pull tool. These tools allow you to create bodies and components from your sketch profiles. You can type in a dimension to determine the exact size that you want. The Chamfer tool. This tool allows you to bevel the edges of your 3D objects. The Fillet tool. This tool allows you to round the edges of your 3D objects. Move and Copy. This tool allows you to move and create copies of your objects. If you want to create the copy, then you have to select this box, and then you can drag or rotate the object to where you want. There are plenty more tools that Fusion 360 has to offer. If you're interested in learning more, feel free to contact us through either email, social media, or our Discord server, which will be posted all in the chat. Those are some of the basic tools that we believe most beginners will find the most useful. And we wanted to cover those just quickly. Does anybody have any questions about what we just went over before we step into designing alliance markers?
All right, so hand.
Hi there, can you hear me?
Yeah,
Yes.
we can.
I'm wondering, is there a quick way for you to maybe enlarge the size of your, what do you call it, like cursor or pointer? I mean, if it's a pain in the butt to do, then you know, move on, of course. But just in terms of seeing like where you're clicking as you're narrating and stuff, I just thought that might be helpful. Anyway, thanks.
Thanks for letting us know.
Can you guys see this better?
No.
No?
What? I don't think it shows up in screen share. The cursor doesn't show up.
Okay.
Can you change it back?
You know, don't worry about it. Thanks. I
Thank you.
appreciate everything you're doing. So just keep it trucking.
The cursor doesn't show up in the screen share apparently. So, all right. So to make our alliance markers here that I have made for this example, we will need to start off by going into the sketch tool and forming sorry, I can't see. Okay, to start off, you need to create a new tab and start off by creating a 63.5 millimeter rectangle on a 63.5 millimeter square. I'm going to be going slowly for the rest of the people here. Once you create the 63.5 millimeter rectangle, you're going to need to make a 10 millimeter outline on each side. Once you do that, you're going to want to copy your sketch. And move it over to the side as an easy way to create a new one. Once you have that, you're going to want to create a line straight through the middle of your copied rectangle and use the circle tool to create a 63.5 millimeter circle. These are going to be the bases of your alliance markers and will now you're going to want to finish your sketch. In this, once you're outside of it, you're going to want to extrude your faces out by 5 millimeters. Because now that your sketch is gone, you're going to want to, well, now that the sketch is gone, you're going to want to go into your sketches dropdown and make it so that your sketch is visible again. Now you're going to want to select your faces and extrude it out the other way by also 5 millimeters. This will create the slides that will go into your holder.
If anybody has any questions, feel free to stop us at any point.
All right. So now that you have your basic alliance markers, you don't have anything to hold them in. What you're going to need to do is hide your sketch and create a new sketch on the base of your square, or on your red alliance marker. In here, you're going to want to create a 5 millimeter wide outline around the outside of your part. So I'm just going to create some 1 millimeter gaps in here, because when you 3D print stuff like this, you have to have space or else it'll not fit properly in your design. This part is pretty tedious and you will have to spend some time on it. I'm going to wait here for a minute to allow people who have not finished it yet to catch up. And if you need to, you can use the sketch dimension tool in order to change the length of the rectangles you have made.
If anybody gets stuck or needs help, just let us know in the chat or by raising your hand.
Okay, so I'm going to continue on now. If you need to go back, then please tell us. All right, so once you're here, you're going to want to hide your main body here, body 2, and you're going to want to extrude your outline out by 63.5 millimeters. Oh, I'm sorry, I missed a step. First, you're going to want to finish the sketch to allow you to press, pull, or extrude your part out by 63.5, negative 63.5 millimeters. This should give you this kind of casing for your part, for your alliance marker. Once you have that, you're going to want to reopen your sketch and then highlight the rest of the bodies underneath it, or the rest of the faces underneath it. And then extrude that down by 3 millimeters. This should give you your basic casing, but there's a few other key parts that will allow it to be a lot cleaner in the final, when you want to print it and use it. So now you're gonna want to use the fillet tool. this tool allows you to, this tool will allow you to fillet the edges down, which allows the part to slide into the thing easier. Do this by 10 millimeters. Once you're here, you're gonna want to, oh wait, okay, so now you have your part, but to mount it onto the robot, you're gonna want to create some holes on the back of it to align with the parts that you use. So here on the back of your part, you're gonna want to create a sketch. And then in here, you're going to want to use the slot tool. We did not cover this, but this is an easy way to create a wide hole. And you're going to, once you have your slot, try and measure it out. So that this is how I like to do it. You bring it down by 15, and then create a hole out by 15 again, and this should allow you to it's just black there. Okay, so once you have this, you're going to want to create your slot using the center to center slot from each point, and then make a hole that is 3.5 millimeters wide.
The 3.5 would be for M3 screws, but if you're using M4, you'd use a larger diameter.
Which would be for 4.4.
Yeah, 4.4, 4.5. The tolerance, it depends on the tolerance of your 3D printer, how much extra room you have. The base size of the screw for M4 is 4 millimeters, and the base size for an M3 screw is 3 millimeters. So the 0.4 or 0.5 extra is just depending on how tight your printer's tolerances are.
Once you have your slot shape, you're going to want to copy that and move it down by however much you need.
However much you need to move it to align with the whole pattern on your robot, whether it's the Rev channels, the Go Build channels, Tetrix, AndyMark.
By all means, after this presentation, you can go and download a part into Fusion 360 to align it with the holes and make sure your part fits properly.
And we'll show you how to design a part or download a part from one of those websites after we finish designing this part.
Yes. So once you have your slots, you're going to want to extrude it out by, or you're just going to want to extrude it to create a hole inside of your part. Oh, sorry. Again, I forgot to finish the sketch. Once you finish it, you're going to want to extrude your part out by 10 millimeters. This should give you these slots in the back of your part. Once you have this, so the reason why we're going to have to now create a slot around it, or a divot, is to allow the screws to not run into the alliance markers when you try and slide them into this part. So to do this, you're going to want to create a sketch again. And you're going to want to go back into the slot, center to center slot. And if you flip it around, you're going to be able to just align it. It'll automatically snap into place, and you'll just be able to make a larger hole around it. Here, we're going to want to do 12 millimeters.
And each end is snapping into the center of the arc that was previously created. And so once it snaps into place, there'll be a little blue circle that appears, and that's how you know you've gotten it where you want it.
Okay, so once you have this sketch, you're going to want to click Finish Sketch, and then extrude these by 3 millimeters as to not make them go through the part completely.
And so now that leaves you room to have the head of your screw in there without the alliance marker running into it. And depending on which screws you are using, you'll need to adjust the depth of that. But for the rev screws, which is what we use, 3 millimeters works.
And now this should be the pretty much finalized part. And to show a little example, you can move it in and out, and it should perfectly fit into the part.
And that'll work the same way with the circle alliance marker as well.
And to do that, I'm going to copy and paste this part. Copy it and drag it over.
Yeah. And when you're copying parts, you got to make sure you select that box. Otherwise, it'll just move the part that you want.
All right. So now for a different, oh wait, so that should be your final part. That should be it, done and complete. Now I'm going to show you how to import parts from GoBuilda and Rev. I'm going to just do one of each. Yeah. So.
Are we sharing our browser?
Yeah, we're sharing the whole thing.
Does anybody have any questions while we are adjusting our screen sharing?
Sure. Yeah, I have a quick question. When you're getting the, whatever you want to call it, the files for these parts to import, you're just getting them from like the GoBuilda or Rev website, like the product description page, and so forth.
Yeah. So in here, let's share our screen and then we can show you. But on their website, depending on which part you want, you'll be able to download a step file. And we will show this in a second. Okay, so here on GoBuilda's website, you'll be able to access all of their parts. But so if you want to like download a channel, and this works for all of their parts. But so in here, we select, let's just select this base one for now. So you can see the product description and stuff. And if you scroll down under downloads, there'll be a step file right here. And so if you click on that, you can download it and it'll pop up here in your downloads. And so GoBuilda, it downloads in a zipped file. So you need to right click to extract it. And then what we usually do is we copy the name of the part from the GoBuilda's website. And then when we extract it, we can rename the file that name. So sorry, hold on. Okay, so now can you see our file
Full
manager? Okay, so once you've downloaded the part, it'll appear here, and then you unzip the folder, and then we renamed the folder the name of the part, and then once you open the folder, the step file of that part will be in there, and then we rename this one as well. Where is it? There it is. So, and we just copied that from the website. And so now you can go back into Fusion, and then if you want to open that file up, you're going to have to come up to the top here, and you're going to want to click Open, or you can press Control-O for the keyboard shortcut. And then once this pops up, there's in the bottom left-hand corner, there's an open from my computer button. And so you want to click that. And then you go to your downloads, and then it'll be not sorted properly. Sorry, hold on. This is not. Why? Where?
All right, so I'm just going to re-download the part in order to make sure it works properly. So go into step file. I'm just going to do this a bit quicker without renaming it, just to get it over with. What I do is I click and drag it into my downloads file. And then once you go back into Fusion, you should be able to reopen the part. Why is it like that?
It's not sorted properly. It's not sorted by date.
All right, so now we should have the part here at the top now. Then once you have that, you can click open and it'll straight bring it right into Fusion. And then once you have it, you can just save it.
And you'll want to save it to whatever folder you have, like wherever you save your parts. So in here, we have a team folder that usually has the year of the season on it. And then we save some of our files in here. But so you can see in this sidebar, usually while designing, we keep this closed. So that way we have a bigger workspace. But it's just this like waffle looking square thing up here. But so from here, you see that you've got the file saved up here, and we'll just rename it really quick. And so that you right click, click rename, and then you can copy and paste the name from that web page that we just took it from. And then once you have the name you like, you got to press enter, and then it'll save. And then if you go back to our alliance markers that we designed earlier, we can save those as well. And then that'll be in your file location. So you can press this drop-down menu and save them in whatever files you want. But so that'll be here, and then you can click save. But so once you've gotten to the step where you want to specify your whole positions for the alliance markers, or in any other part that you're designing, and you want to insert a separate design, you're going to want to have this data panel open, and you go to the part you want to insert. In this case, it'll be that go build a U channel. And if you right click, you can see all of these options pop up. And the second one here, the insert into current design, if you click on that, it'll load for a little bit, but it'll bring that design into this design that you've been working on. And so you can move it around. Once it's in here, you can rotate it however. But if you want to like center it onto the alliance markers, there's a pretty cool tool that we didn't cover earlier, but it's the align tool. And it's pretty simple. The object that you want to move, you select that one first. And so you can select different faces. For this case, center hole of the U channel. And so you can select that, and you see how it's got this box around the center hole here. And then you can go to the object where you want to line it up with. And in this case, it'll be the back of this alliance marker. And we'll click the center here. And it'll move the U channel to that face that we just selected. And then from here, you can angle it however you want using this angle button. This flip one, it'll flip to the separate side of the face. In this case, it brought it correctly. So we'll press OK once we get it there. And then from here, you can line up the holes with your U channel or C channel or whatever part that you're designing. And then just some little tricks for a separate file. If you change this U-channel file at any point and save it as a separate version, you'll be able to go into here where your file is saved and then update. It'll give you a little yellow warning sign, and then you'll be able to update the file to its newest version. And then as long as this little link logo is here, it's always linked back to that previous file. So if you update it or modify it, you can always adjust. And so you can see right here, this will be how to remove the link, which we don't usually use when you want it to be modified, when you're actively modifying the file. But so in here, like, we can go back into our sketch, our last sketch here, and edit this. And so, sorry, I'm just going to make a new sketch. So if we make a new sketch here, we can see this whole pattern here. So if you press P on your keyboard, it's a shortcut for project. And so from here, you can select all of the geometry that you want to move to the plane, to the sketch plane. And so we'll click this entire face, and then it'll project link, and then it'll show the filter. And you press OK, and then you can hide the U channel. And so here you can see the holes we made earlier wouldn't align with this Go Build a piece, but now we know where the holes are, so we can create the slots that we need in this sketch. So yeah. Okay. And so in here we can just, so if you want to access a previous sketch before you added data, it's not going to be able to show your like new added. So like if we went back to sketch 4 and we wanted to edit it, which is right clicking. So if you want to edit a previous sketch, you got to right click on it, and then it'll show this list here. But so the third one down will be edit sketch, and you can click on that, and it'll go back into that sketch workspace that we discussed earlier, and it'll show you what you did, and then you can edit it as well. But so in here, as you can see, it doesn't show the U channel sketch that we made earlier. So we're going to have to make a new sketch for these holes, or you can use the measure tool and select this point, the center, to see the distance here, and then go back and edit your previous sketch. But the best solution that we usually use is just to make a new sketch where you can see the U channel. So you can see, we'll delete our previous slot holes that we made, so that way they don't interfere with what we're working on right now. And we just use the timeline, and you can see at the bottom here, it shows all of our actions in order. And so you can go in and like right click to edit what happened, delete it, rename it. So like here in the extrude, you can come in and edit the feature and then adjust distances and stuff. But so now that we've gotten rid of the slots, we can show you, we can make a new sketch. And as long as this other sketch is on, the previous one with the U channel, you can see it here. And so these holes, they're shown here. These holes are, because they're made with GoBuilda's tools, they have a much tighter tolerance than 3D printers can handle. And so if you want to adjust or if you want to make holes for your 3D printed part, you're going to want to come in here and make the holes bigger. So what we usually do is we align with the center of this hole. It's kind of difficult to see. Hold on. We want to align with the center of the hole, and it'll snap into place if you have that setting on. And then you can adjust for M4 screws would be 4.5. Depending on your printer, that's going to change. And so you can do that for all the corners. And so here we're just typing in the number we want, so it defines the diameter. And then we can finish the sketch. And then we'll go here and turn off the sketch with the U channel on. And then we've got these holes. So then if you want to extrude them, you can click on them, each one. And then if you hold the control key, then you can select multiple objects or faces. And then you can go in here and extrude them. Oops, okay. We'll hide these first two alliance markers so that we can see what we're doing. So once we've selected these faces, we can go to the other side and then drag this all the way through to cut the holes through. And so you can see if we unhide the U channel, we can see that we've got holes here now, so we can screw them in. And then we want to, like we did earlier with the slots, we want to inset the screw holes. So we'll want to make a sketch on this side of the plane. And it'll auto snap to the circle or to the center of the circle. And for go build a screws, we usually do 8 or 9 millimeters offset if we're countersinking the screws. So you're going to want to do that for each one of your holes. And so again, it'll just snap to the center of your circle. And then we type in the dimension we want. And so you can finish your sketch once you've got all the circles in. And then you're going to want to come up here to the extrude and then select all of these rings around them. And then you can drag this arrow back into your part. I think for go build a screws, we usually do 3 millimeters. And then once you've done it 3 millimeters, or you can come in here and type in -3, and it's going to be negative because it's going into the part. So it's, yeah. And then there's different operations you can do here, which we didn't cover before, but there's the join, cut, intersect, new body, and component. In this case, we're going to want to use cut because we want to remove material. The join is adding new material or combining with current bodies or whatnot. And then there's intersect, which creates the body between two other objects. And then the new body creates a new component rather than joining. And then same with new component. And so once we make sure we've got cut and then the right distance, we can select OK. And so now you've got your insert holes so that you can countersink your screws. And then if we want to put the screws in this file as well, we can go back to the Go Build a page and then look at the screws that we want to get. And so that'll be in hardware. So we look at screws. And then for Go Build a screws, we usually use the button head ones, but it's just personal preference. But so we can go in here and select whatever screw size we're going to use. And so you can like find the parts that you currently have and then download those into CAD. So the cool thing about doing this is you're able to design a robot in CAD without having any 3D printed parts, because you can download all of GoBuilda's or Rev's or Andy Mark's or Tetrix's parts so that you can design it without having to without the need of 3D printing anything. And so now that you've got the screw open, you're going to want to save and then name the screw. And then save it into the folder you want. And then so you can see on the left side of the screen, you can see it saved into our folder. So we can go back into the alliance markers and do the same thing that we did earlier, where we right click on the design, we click insert into current design, and it'll load for a little bit, and then it should appear. And then you can either align it manually or use that align tool we did earlier. So from here, with this align tool, you're going to want to select the base edge of the screw and then the center hole that you want the screw to line up to, and it'll just snap right into place. And you can see the head of the screw is hidden, so it won't scrape the alliance marker while we're putting it in, but you can still access it completely.
And we're also, and because there's 4 screw holes, you're going to want to copy that and paste it 4 separate times or 3 different times.
Yeah.
And another way for you to copy and paste the objects is double clicking and then doing Control C and then Control V. It's my personal preference.
Keyboard shortcuts. When you design a lot, you learn a lot of the shortcuts. And so you can see here for that last screw, he just manually dragged it, which is totally fine.
It's just less accurate.
Yeah. But in this case, we don't need the screws to be perfectly accurate. And so we can go in and turn on the visibility for the U channel in that side browser. And so now you can see all the screws are in there. And then if you want to go even further, you can go into GoBuilda and download the nuts. So that way you have all of your fasteners in your designs. Usually when you have a full robot, it gets really laggy on your computer if you have a bunch of the fasteners in there. So what we do is, because we have so many separate components, we have our screws to verify tolerances and how things line up in our separate components. But when we're putting them into the main robot, we make sure those are turned off. So that way the computer doesn't get really slow and difficult to work with.
And one more thing that I would like to go over is downloading parts from Rev. It's the same exact process, just with Rev parts. So here I have this random corner bracket here. And if you it's right down here under CAD and drawings, you just select the CAD step file. It'll open this. Then you can just directly save it wherever you want to save it. And then you can open your part, just like we've done with all of the GoBuilda parts. Just like that. And then you'd want to save it.
Does anybody have any questions? Okay. So we're now going to move on to showing you how to export your files so that you can 3D print them. And so there's a couple different ways to do this. The simplest way that we found is coming up here into this top file button, and you click on it, and then there's this 3D printing tab. And so if you select that, it'll open up this menu where it tells you which parts you've selected, but it also tells you a format. We usually use STL binary, but you can use 3MF files, object files, ASCII files. And then you want to make sure the unit type is correct. Usually Fusion does a pretty good job of saving what unit type you have as your in your settings, which in this case is millimeters. But if you want to change that to centimeters, meters, inches, or feet, you can do that here. And then so we don't want to preview the mesh in Fusion because usually that's not necessary. The refinement is just how detailed your part's going to be. For a lot of like robotics parts, medium to low is good. But if you're designing something extremely high detailed, you're going to want to select high. We've never had a use case for that though. And then so once you've got this open, you're going to want to select the part that you want to export. and we're going to do one at a time here. So we've got the square alliance marker, which is going to be the red one. And so once you've got that selected, you're going to want to select OK. And then it'll pop this tab up. And so you're going to want to name this body that you have. And so we'll say red alliance marker. And then it'll prompt you again here for the file type, and it's STL. And then we don't want to save this into our Fusion cloud because it's already saved in our main file, but we do want to save it to computers. So we got to make sure this box is checked. And then this is just your file location where you want it on your computer. And so once all this information is good, you can click save.
Okay, so once you have saved it, do they have Prusa Slicer? Just good. So if you have Prusa Slicer downloaded, then you're going to want to open it.
This also works with any slicer software, but we have Prusa printers, so we use Prusas.
Whichever slicer software you use, this is how you bring it into it. So for the Prusa Slicer, you want to click Add, and then you want to click the part that you've just gotten. I just look for it in my most recently saved. Select it and open it, and then it should show up directly into the Prusa Slicer. Would you like to go over settings?
Yeah. So some of the basic settings of Prusa Slicer, a lot of the settings correlate to like Cura and a lot of other slicers, but they're just in slightly different locations and the interface looks differently. But so in Prusa Slicer, the first thing you're going to do is make sure you have the correct printer selected. In our case, it's a Mark III S Plus. We also have a Prusa Mini, which is why we have two here. But we make sure we got the right printer selected. And then the type of filament. In this profile, we don't have very many filaments downloaded. But when you're using like generic PLA, usually Amazon Basic PLA or Overture PLA or whatever generic PLA, you can select that. That just changes slightly different preferences and settings. And then your print settings up here. Usually if you want a decent quality model and a decently fast printing model, you're going to want to go with 0.2 millimeter layer height. And then these are just preset profiles. You can edit all of these later. But this is what we'll stick to for now. And so supports. This model doesn't have any overhangs or anything, so we don't need to add supports. And then the infill. This part isn't holding anything structural. It's not, it doesn't need to be very strong. It's just to signify which alliance you're on. So we're going to lower the infill so that way it prints faster. And then the brim here, that just adds material at the base, so that way it sticks to you. So we don't need to add a brim here. And then you can go ahead and slice the model. And you can see here it'll take 1 hour and 12 minutes to print. And on this side, you can scroll up and down and see like all the infill and the inside and stuff. And so this will be your red alliance marker. So you want to make sure to print this with red material, or you can paint or color it afterwards. Yeah, and so because you'll need 2 alliance markers on your robot, we can come in here and make a duplicate of it so that we have 2 printing at the same time. And so to do that, we'll move this over so that way we have room for 2. And then while it's selected, you can press Control-C, which is copy, and then you can press Control-V on your keyboard, which is paste. And then you can drag this one over too. So now we have 2 alliance markers on the bed. And then if you slice it again, we've got 2 red alliance markers printing here. And so once all of your settings are good, then you can export it. Then you can export your file and then name it however you want. But so like then we can come in here and 3D print the blue alliance marker and the case as well. So we'll come here, we'll select the blue alliance marker, we'll make sure all of these are good, STL binary, millimeter, refinements medium, and then we'll select OK. And then we'll have this, name it blue alliance marker. And then again, we make sure it's STL file, saved to my computer, and it's in the right location. I'm going to click save. And then we can open a new Prusa Slicer window. And then up here, we can add another part. And so the blue alliance marker pops up right here. You can click open. And so we'll start off by copying it so that we have two. And then you can make sure all of your settings are good. Usually Prusa Slicer does a good job of transferring settings between uses. So we'll make sure this infill is 5%. And then we'll make sure the model doesn't need any supports. There's no overhang, so we don't need any supports here. And then we can go ahead and slice the model. And so we can check that the infill is good. And then now we can get ready to slice the case for our alliance marker. So we'll open file, we'll 3D print, and then we'll select the case that we want to print. And then we make sure it's STL, millimeter, medium. You press OK, and then you name it. STL file, save to my computer, make sure it's in the correct location, and then you click save. And then we'll open another Prusa Slicer window or other slicer that you're using. And then you come in here and add whichever model you want. And so in here, there's a couple different ways to print this model, because in this orientation, there's going to be this wall that overhangs that would need support material. But because the support material would be right underneath here, that means it's going to be right on top of this face, which is going to make it difficult to remove. So what we can do is we can select this place on face tool over here. And so once we select that, it'll highlight different faces of the model. And so we'll select the bottom here. So that way it stands up. And then you can see there's the only overhangs are the top of these circles, which are small enough where the printer can just bridge without any support material. And so we can make sure our settings are good again. So up here at the top, print settings, we make sure it's 0.2. If you need more detail, you can go smaller, 0.1, 0.15. Or if you don't care about detail at all and you just want it to print as fast as possible, you can go in here and press 0.3, which basically these just adjust the height of each layer that the printer is making. So a taller layer height would mean there's less layers of the print, meaning it can print faster. 0.2 is a pretty good one to stick with, if like a pretty good medium. And so in here, again, this isn't doing anything structural. All it's doing is holding itself and the alliance marker. So we can stick with a lower infill, and then we can slice. And so as you can see here, the blue are the overhangs, but as you can see, they're super small. So the printer can just bridge right over them, and it's bridging over here too. But so then you can go through and make sure everything looks good and nothing out of the ordinary. And then you can export that model onto your drive or straight to your printer.
If you were to want to use supports for the holes to make it a bit cleaner, to add the supports, what you have to do is go back into the selected portion of it, and you want to click paint on supports. The easiest way to do this is to click automatic painting, but it doesn't always do it in the right spots. So you might want to go in there manually and just click on the top of the holes. And once you've done that, you want to, should I go into the typos? So in up here at the top, there's 4 different menus. You want to go into print settings, and in here there is the support material, and
so in here, the support material, there's all of your settings, but as you can see, there's a couple grayed out, and that's because you don't have supports turned on. So up here, supports, right now they're none, so they're turned off. And so there's 3 different options. There's everywhere, which means it'll just place supports wherever there's an overhang. For support enforcers only, which is where we painted. So you can see this blue part here. So if you select that, it's just where we painted the part. And then support on build plate only is kind of like everywhere, but it tries to avoid placing support material on the part itself. And so for this one, we'll select for support enforcers only. And then now we can go back into print settings up here and then go down to support material. And we make sure and see, so now some of this is grayed out. There's still other things that are grayed out due to locked, like yours, depending on your settings and preferences. But so in style, the default is grid, but there's 3. There's grid, snug, and organic. And usually grid and snug are pretty good, but they're kind of difficult to remove sometimes. And so we usually use organic. And all 3 of these just depend on the geometry of your part. But we found that organic seems to work the best. And so now you can go back here to exit the paint on supports section. You can click on it again, and it'll go back to your model here. And then so once we've got all the support settings turned on, we can slice. And you can see here that it adds all this green. It's adding support material to your part. And so after it's done printing, you can just break it away. It should be pretty simple to remove. But so you can see here, it's supporting the tops of these holes. So that way, if you have like a bigger area where the printer won't be able to bridge over, like a bigger overhang, the support material will allow it to cover that area. Yeah. Are there any questions? Just in case we move too fast or somebody got lost throughout this process, we'll be uploading CAD tutorial videos to our YouTube channel later in the season. And this Zoom has been recorded and will be on the First Nevada. And you'll have access to it on the First Nevada page. Scott, do you have anything to say?
No, not particularly. Great job. Is that kind of the end of the presentation part?
Yeah.
Okay. Yeah. So, I mean, does anyone, maybe we'll just start with, does anyone on the call have any, well, they already asked for questions. So questions about, what they did. But if you don't have questions about what they did, do you have any other, let's say, open-ended questions about things you might like to see, or you're trying to figure out how to do something in, Fusion 360, things like that, or about the 3D printing? This might be a good opportunity, to tap into their experience.
And so it looks like Anthony has a question
Yeah.
about like file management. He asked, if there's time, could you comment on how you organize files, such as go build a parts so that team members can access? And so there's a couple different ways to do it. But so in here, we'll just use this project as an example. In this waffle menu, we made this folder. It's the VCSC 2023 folder. And so you can open this up and there's people. Right now, we don't have anybody in this specific folder, but we will have team folders where we can share files between each other, and that'll just be in the cloud. But so in this people, there's this invite members tab. And so you can click on that and it'll open up in your browser your Autodesk page. And so, but can they see this? No, you can't see that. Hold on, sorry. Okay, so once we've in Fusion, once we click this invite members tab, it opened up this window in our browser. And so in here, you can add the email addresses of team members or friends or whatever, that whoever you want this folder to be shared with. And then you can select different roles for them. And so viewer would just be to like look at the design and comment on it, but they can't do anything with it. They can't edit it. Reader is pretty similar, just some extra stuff. Editor, that's usually what most teams use between team members. But if you want everybody to have like the same level of access, you could use manager or assistant or administrator, sorry. And so this just gives full access to that file. And so you can type in whoever's email you want to add, so different team members, and then you can send them the invitation, and then they should get it in their email, and then they'll be added to the folder. And so they'll be able to see all of the parts designed. And right now, this folder isn't organized the best, but like last season, we had like different versions of our robot. We had in our main Silver Circuits folder, we had like one folder for version 1 robot, one folder for version 2 robot. And then in each there, we had different folders for versions of like our output or input. And so that way we could always go back and be like, okay, this new version is terrible. We need to go back to the old one and edit it slightly differently or whatever. So that's kind of how you can, share designs between people. And it's all saved in the cloud, so anybody can access it on their own computers or whatever.
Along those lines, it sounds like you say you can create different versions. Is it something similar to GitHub where you can have like different version branches or things like that? Or,
Kind of. It's not as fancy because we just did it manually. We copied our old design and then made a new one to edit it. But there are like version controls, I believe, inside the design. Oh yeah. So in here, there's the version controls. We'll go to a part that we've messed with a little bit. So in here, it says like V16 in the corner, and it has a little drop down. And so you can see here, and it'll show all of the versions. So you can look back and so like right here, it just shows like separate times you've saved. But you can go back if there's a significant change that you made and are like, okay, that didn't work, or hey, I kind of liked that a little better. You can go back and in the history and see where that was, and then make that your new design, like update it to that one. Anthony, did that kind of answer your question?
Yeah, that's great. Thanks.
Does anybody else have anything? Any questions, concerns?
I apologize if I missed it, but on the 3D printing, I could didn't recall, did it decide automatically, or do you have advice on like deciding the orientation? I assume like when you were printing that, you printed it upright because that was the least, I guess, the orientation where there'd be the least amount that would need to be supported. So like, for instance, if you printed it flat, then you'd have both those sides, those in essence are overhangs, they would be hanging in free space. So by printing it vertically like that, that was, I guess, the orientation where, it would not require at least as much support, or as you point out, maybe no support, but is that how you kind of decide which orientation you're going to use to print a 3D object?
Yeah, there's a couple different ways. So when you put in the file from Fusion 360 or whatever design software you're using, it'll keep the orientation that it was in that CAD software. But so there's a couple different factors that come into the placement of your design and orientation when you're printing it. The first and biggest one that we look at is use of support materials. We kind of want to minimize that. And in this case, usually this smaller pulls don't require supports, but it's kind of a good way to just make sure you've got the defined circle to use the supports. But another thing is the strength of your part. So because it's printing it in layers like this, if you pull hard enough, it will separate at the layer. And depending on the material, it'll take less force, like PLA, which is pretty common and what we used mostly last season. The layer adhesion between two layers isn't very strong. So you want to choose orientations where all of the load isn't going across layers. So if you have a pulling force, like let's say you're pulling this wall away from this wall, you'd want to have it oriented like this, because then you're not pulling against layers, because the layers are stacked on each other, so there's not forces between those. But if you had it like this and you chose to pull between the two walls, you can see how it would just separate at the layer because it's printing top down or bottom up. Wow. So there's a couple reasons to pick different orientations, and we've even had some parts where like we print it like this just because of random layer orientations that make it super strong. It does require more supports, but depending on the strength, like if it's a super structural part, some extra supports to make sure it doesn't break is going to be worth it. And while you are designing your components, try to keep in mind print orientation and how the layers are going to go, depending on your part and what it's going to be used for. So like last year, there's one component on our output, though, it was the wrist, and it basically just held a servo, but that servo had a lot of weight on it. So when we were designing it, we made sure that certain parts where there was a lot of force were thick enough to support that weight, and then we made sure the orientation was good enough so that there wasn't any force on the layers, and through iterations, we've found that how to design that part perfectly. Like in the first 2 or 3 times we designed it, it would just break super easily. Like even at Worlds in one of our matches, it ended up breaking and our output just became useless. And so through iterations, we found the best version. So, I mean, it's very rare that we get a perfect part to start with. So just know that, failed designs are a thing.
Well, going back to what you said before, this obviously designing the marker is not load bearing, but I guess for that use case where you're using it for the servo, I assumed you used a lot more infill on that part, just because, as you say, it was bearing a load.
Yeah, if it was bearing a load, you could use more infill. And then there's different patterns as well. So if you go into your print settings and then in infill, Like you can change the density. 15 to 25% is usually where we go. If the part's like super thin and needs to be structural, we'll go up to 100. But for most cases, we stick between like 15 and 25 for structural parts. And then the fill pattern gyroid is pretty much the best based on all orientations. It handles compression and tension pretty well. And then between the X, Y, and Z axes, it's the most consistent. But if you know you have a part that's going to experience force on one specific plane, you can select other patterns where it can handle that direction of force better. But we usually stick with gyroid because there's a lot of dynamic forces in FTC, like whether you're crashing into a robot where you could have force that is unexpected in a direction. The gyroid kind of gives support in all directions. And so another way to add strength to your parts is up here in layers and perimeters. And so a good way to make things stronger is to make like the walls thicker, especially in 3D printing parts. You can kind of see here how the walls are pretty thin. So if you go to print settings and layers and perimeters, and then under the vertical shells and perimeters tab here, you can up the amount of perimeters. So like the default's usually 2, but you can go to like 4, 5, 6. And it just makes the walls that much thicker. So that way it can handle more force. And depending on your material, depending on your material, you'd want to change this. So like last season, during like the main season, we mostly stuck with PLA, but after Worlds, going into some off-season competitions, we started to switch up the materials. So like we were using like nylon because it has a higher durability. It's slightly more flexible. So you kind of want to make it so there's more perimeters. So that way it doesn't like bend as much, depending on the part you want. If you want it to bend, you'd want to make thinner walls. But so that's a pretty good way to make your parts stronger without adding much print time. I mean, it still went to 4 hours. So depending on the print geometry, it, takes different amounts of time. So like,
and this is a little bit off topic, but I'm just kind of curious because you mentioned you're using it for servos. So, the vendors have kind of their own servo brackets and things like that. Are you using your 3D printed kind of custom ones in lieu of that, or is that something you're kind of adding on to the existing bracket?
We've found the aren't as good. They are either too bulky for us or add excessive weight where we don't need. And so the 3D printing allows for a much more custom and smaller piece because you don't have to design around this separate mount. You kind of just put a hole for the servo, make sure the screw holes line up. And so that way there's no like excess material kind of going around something where you're just going around that specific servo. And then that's the same with like CNC parts. If you don't need the servo mount, you can cut in your own or design in your own spot. And that's the same thing with motors. Like we design motor brackets ourselves. We design servo brackets. So that way it's all custom. It all fits where we want. And then sometimes, especially with motors, because they're pretty heavy, the off-the-shelf brackets, depending on the amount of force that's going through it, wobble a little bit, which causes some inconsistencies depending on the use case for the motor or servo. So by designing our own, we can make sure that there's no wobble in weird directions, and then we can make sure it fits exactly where we want on the robot.
That's good. I don't know if this conversation sparked any other questions. Does anyone else on the call have any questions or anything they want to ask? Well, Don, I'll ask one more. I noticed when you were in the CAD software, Fusion 360, it seems to have kind of a snap to feature. I assume that can be turned on or off, but so like in this case, the center of a circle or things like that. So like if you get close to that part of the, a feature of the design, it kind of highlights it or shows, you're getting close to it and tries to snap to it. Is there a way to set like custom snap points? Like, so if you have an object, you're like, well, I want it to be able to either do dimensions from this point or snapped on this point. Can you like pick a point on the sketch and say, this is an important point, so when I get close to this, snap to this, even if it's not a corner or a center or something like that?
One way that we do it, there's not like a specific way where you can say this point's important, but if you do have points, it just automatically snaps there if you get close enough. But if we want there to be a specific point where there's not already, there's a way to, I'll just draw a sketch on the back of this so you can kind of see what I'm doing. We usually use a line. So like, let's say we want a point right here to be pretty important, where we want a snap point. You can come here and draw a line, and you can come down for, let's say 12 millimeters, just for an example. And so I'm not sure why that was collapsed, but so in here, so right now this is a but if you don't want it is the screen for it. And then you can change that to construction. So that way you can see now the line's going to be dashed. And so because we made this dashed line, it's not going to affect the face at all, but it'll still give us this point here where we can just snap right to it. Whereas before we couldn't snap there. So that's a pretty good way of being able to create points without affecting external geometry.
Okay. In terms of like how you use the CAD software, clearly you're using it to make some sub-assemblies or other kind of parts that you put on your robot. Do you use it to build the entire robot from the ground up, or do you kind of make the robot first in a season and then go back and kind of render it afterwards, kind of create it after the fact for judging and things like that to show off your CAD drawings? Or kind of what order do you do it in? Like, do you start with the robot and then CAD it up, or do you start in CAD to create it and then build it from that?
In previous seasons, like the season that we first started using CAD, we would build the robot first and then put it in CAD. But as we've gotten more experience with CAD, we've been able to design the robot in CAD without touching any hardware and then go into real life and build it, which has proven like super beneficial to us once we have the knowledge of being able to do that, because we save time in building. Because once we've put it together in CAD, we can go through a couple versions just in CAD and seeing like, oh, these parts don't align. Oh, this needs to be bigger. Oh, this piece doesn't actually fit here. It allows us to go through a couple of the versions rather than building it and realizing it and then having to rebuild it. It's just faster to run through cycles in iterations in CAD than it is in real life. And so this season, we've already got our entire robot designed in CAD, and we're actually working on building it in the next couple of weeks. And it just helps with speed and reliability, because then there's no unexpected things when you're building it, because you've already put it together in CAD. So you know exactly how it's supposed to go. You kind of have this idea of how things fit together, rather than real life of learning in the moment how things go together and kind of having to adjust things on the fly.
You mentioned the spacing. Does the CAD software, in essence, either stop you or warn you if something's physically impossible, two objects occupying the same space or something like that?
In different CAD softwares, there are, like in SolidWorks, they have that. In Fusion 360, I don't believe they do. But what you can kind of do is you can use the align tool that we showed earlier to align parts together. And then you can also use the inspect tool, that measure tool that we discussed earlier, where you can measure distances between parts to make sure that there is a real life tolerance in there, because things in CAD don't, perfectly fit well in real life. But because we've done so much CAD, we've kind of learned what to account for in the real world. Because when we first started designing things in CAD, we would design them with little to no tolerance and then go and build it and be like, why isn't it working? It worked in CAD. But things in real life they have slight differences than in CAD, because CAD's perfect in real life is not. And so it's mostly through experience where we've learned to make sure that things fit together well and account for real life scenarios.
Yeah. I suppose the other use case would be like, especially specific to FTC, setting an 18-inch cube and then kind of ensuring as you're building, you're not going outside of that. It sounds like it doesn't do that, maybe like SolidWorks does, but is that something you guys just kind of check as you go along? It's like you're building just to make sure you're not exceeding a dimension, I guess.
Yeah, and so this season, what we've done is for like designing our chassis, what we did is we had a box around it that was the size requirements that we wanted to fit. And so that could be the 18 inches by 18 inches by 18 inches, or you could do, if you wanted to be small, you could
or
do
something shorter. Yeah, I was gonna say this year it might not be needed.
Yeah, so you can have that box turned on to where you can always see, oh, this is actually outside of the area that I need, so I'm gonna need to make this smaller, or you can double check things with it. And so that's helpful in CAD, because then you don't need to, like, if you're building compared to building in real life, you need to compare everything a lot, or you compare it at the end and realize it's way too big, or it could have been bigger. Where in CAD you can kind of get exactly what you want, because you can check way more often without it being I don't know. Yeah.
Do you guys have any suggestions, I guess, for people on the call who might be just getting started with the CAD? I mean, did you start by just using, for instance, the kind of pre-made parts, the ones you downloaded from Rev or GoBuilda or Pitsco, Tetrix, or did you start more by trying to sketch, free sketch, and just try to build objects and kind of learn from that experience?
Yeah. So we first started like over the summer. We learned it over the summer, and we mostly used the pre-designed parts, like from Rev, GoBuilda, other companies. But one thing we tried to do is we tried to like give ourselves a project, whether it's for FTC or whether it's for like a cup holder or a pen holder for a desk, like small projects, just to get used to the free sketching. And that gave us some experience in it. And then it gave us the confidence of like, oh yeah, we can design parts that work. And so once we got used to building components in CAD with the pre-designed parts, then we started being able to design our own and go into, designing intake arms or chassis walls or, linear slide systems.
Okay, that's good advice. Maybe it's a good opportunity to check to see if anyone on the call has any questions. And good opportunity to take if there's anything you've been kind of wondering about, or especially how to get started or how to do a specific task within, I guess, either the CAD software or in the slicer software. You find that the slicer software, not only the one you're using, but just generally are pretty good about, it sounded like when you were walking through it, it's pretty good about warning, I guess, things that are impossible or won't necessarily work out. I mean, is that generally too, you think, if you bring an object in and say, I'm going to print this, and basically it tells you, no, that's not going to work?
Yeah. We have most, I've messed around with a couple other slicer softwares, but I mostly use Prusa Slicer. But yeah, it does a really good job of letting you know if like there's a problem with that's like if the part's not going to stick to the bed because of little surface area, it'll let you know. Or if there's overhangs, like big overhangs that can't be done, it'll show, you know, the blue here, and you can obviously see that there's a bunch of blue, and it's like, okay, I should probably put some support materials there. And so it'll give you recommendations and stuff on how to make your parts better. And so like even if it's off the bed here, it'll show blue and then dark blue that's out. So if you have a super big model that doesn't fit on your printer, it'll let you know. Like it's not going to try to print. And then even if it's like, I think if it's below the bed and you try to slice it, I guess it doesn't warn you, but it's pretty obvious.
You just want a shorter one then.
Yeah. And so like if it's above your bed, it automatically goes to the base of your bed. So like if you try to lift it up, whoopsies, it'll drop down to the bed and stuff. So certain things like here. So if you have it rotated here and you try to slice it, in some slicers, like newer versions, it'll let you know that there's not very good bed adhesion here. I think because we have supports on, it's not warning us, but it's right here. So right here, it'll like warn you saying print stability issues, because it's got such a small contact area, which it definitely wouldn't print correctly. So then you can come back and adjust it.
Okay. Are there any other questions? Seems like we may have exhausted questions. Hard as I tried to drag it out. Maybe that's a sign you guys did such a great job. Well, we certainly do appreciate it today. Like I say, kind of walking through it. It was already asked, the video would be up, so we have recorded it. And assuming all other technical things go well, we'll go ahead and get it posted, usually within 24 hours. And I did put the playlist that we're using for this season for FTC in the chat for First Nevada. So you can find that video there and any of our other videos. Like right now, there's just two. There's just a kickoff and the first coaches corner. But like I say, this will be the next one. And I guess just as a thought for what's upcoming, we have a coaches corner again later this month, on Tuesday, I think the 24th, if I'm not mistaken. So be sure to check that out for our coaches that are on the call. For all of you who joined us today, we certainly do appreciate it. Want to thank VC Silver Circuits, of course, for taking the time to put all this together and share their knowledge with us. And again, thank you for your time, and hope to see you at an event very soon, and hope you have a great day.